Hello, beautiful people. Hope so you're all having an amazing day because I'm having an amazing day. Today, we are going to cover the topic of recursion in C++. It's an other technique. In our previous tutorials, we discussed iteration or loops. It's a very powerful technique for certain problems, actually, for which the result would otherwise be very difficult. So let's move towards the basic definition. It's actually the process of solving a problem by reducing it to the smaller version of itself. There are two types of recursions: direct recursions and indirect recursions. Okay, this concept would be more clear when we will get to our Visual Studio. So let's move to it's the direct recursion when the function calls itself. However, a function that calls another function and eventually results in the original function call is called as indirectly recursive. So let's move to Visual Studio. First of all, write the pre-perspective. IOStream is the header file which contains input-output functions. It's an idea like robots calling robot. It looks a little weird. That's why most of the computer science student hates this topic. Now let's move to make the function definition. Our function name would be dude. Now make the prototype. Now make the function call. And in our function, the a simple statement would be present. I love mangoes. And in the function, we will call the function itself. And our function name is dodev. So here we go. The function would now be infinite. Okay. It's the example of direct function. Okay. So now run the program here. And we are getting the result over and over again. At a certain time, the result will break. The system will break. Okay. If we keep it and okay, here we go. The system runs out and the system has been stopped. Okay. We have to delete this and make it like this. The system runs out of memory. So if we do the same example with the indirect recursion, then what happens? Let's see. The definition of indirect recursion is that when the function call another function, and it could be deep. We will do a little bit deep example. Our second function name would be, let's say, Robert. Robert's calling Dodevdone, and our third function would be, let's say, duck. And duck function calling Robert. But in fact, the whole program is calling Dodevdone ultimately. If we run the program, we will get the same result in which the system will run out of memory and system will crash like you seen before. I'm going to run this program. We'll get the same result, but we have to make the prototype. We forgot actually. So what if I make the prototypes here? What our function name would be duck, and here we go. Now let's run the program. We will get the same result, and the I love mangoes will keep on writing itself, and the system will run out of memory. And you can see on the left side that process memory is continuously increasing. We have to regain the previous position of the system by pressing continue here. And it was the example of indirect. in which function was calling another function, and ultimately the last function called the this function Dodevdone. So here we go, is calling the, and is calling, it's the same thing, and ultimately we get the result. Here we go. Okay, this also told you the example of infinite recursion. What is infinite recursion? When the system runs out, runs out of memory. Why? Because system memory is finite. And when with each call to the function, the system are required to allocate memory for the variables and the formal parameters which are present in function. So at certain time, the system runs out of memory because no space left for the variables and other formal parameter. So here are example. If we do examples for when we do example for the our universities and software houses, we are required to get the same or specific certain result. So in order to get this, we need to apply a certain condition, and we call this condition in recursion as base case. Let's move towards the example in which we will learn the base case. What actually is base case? Okay. Base case is actually a terminating scenario in recursion that do not use recursion to produce an answer. We are going to print factorials. For those who don't know, it's actually the to multiply a series of descending natural number. If let's say if we say that what would be the factorial of n, then factorial of n would be the product of all smaller number less than n and greater than 0. So here we are taking example of 5 factorial. 5 factorial is actually 5 multiplied by 4 is 20. 20 multiplied by 3 is 60, and 60 multiplied by 2 is 120, and multiplied by 1 is 120 again. So up till now the result and condition is okay, but if we multiply 120 with 0, we will get again the 0, which is not the actual result. So in order to save ourselves from such condition, we apply another case, which is base case in recursion, which we will by which we will not only stop the program, but we will also get the specific certain result. So let's move towards Visual Studio to perform factorial using recursion. Make our screen a little larger. Write the same program over again. And the return statement. Write prototype here. Our function name would be, let's say, fact. So here we go. Also write the we will use pass by value here. We want to get the factorial of 5, let's say. We have to change the prototypes because int is void is not suitable for the value returning, and one parameter because it is passing value into the function definition. Okay, I'm going to make program for this. So here we go. In this we are getting return our actual parameter is a here. Let's say return a multiplied by, for the math student who already know that what's the formula of uh, finding factorial. It's actually, I can write here the general formula for you guys. It's actually the general formula of finding factorial, if you guys don't know. So here we go. I'm using the same formula over again, and this is our base case. When the our value reaches to 0, as I told you before, then it will return 1 so that result can be saved and program can be ended successfully. Here our program is complete. Now let's run the program and find the factorial of 5. Yes, it is 120. We are right here. So in this program, we are not only getting our program stopped, but also we are getting the correct result. So in our next tutorial, we are going to perform even more and difficult advanced level examples on recursion for you guys. Uh, in the end, if you like my tutorial, don't forget to subscribe my channel, which really encourages us. And if you want to test your knowledge of C++ or Java, here are two apps. C++ programming quiz app and core Java quiz. Link of both apps will be in comment section. Like always, thanks for watching. Peace.